Hey, everybody. Welcome back. This is Calculus 3 in the fall semester of 2022 at College of the Sequoias. Today, we're looking at planes in 3 space. This is 11.6 in Anton 11th edition. So we can describe a plane as being having a vector that's normal to that plane. In this case, we have vector n. Now, there's a lot of planes that have that as normal. Anything that's parallel to that plane is going to have that same normal. But by picking P naught, that chooses a plane. It chooses a starting point. And so how can we use that to write an equation? Well, if we use P naught with coordinates x naught, y naught, and z naught, and pick some other point P in the plane with x, y, and z, we can see that this relationship has to be true. The vector P naught P and the vector n need to be orthogonal. So how can we confirm P naught P and vector n are orthogonal? We had a nice little handy tool, the dot product. The dot product has to be 0. So P naught P in equation form is x minus, or vector form is x minus x naught, y minus y naught, and z minus z naught. We're going to dot that with our vector n, which will have components a, b, and c. And since the dot product has to equal 0 for orthogonality or normality, we can go ahead and dot that out. And we get a times x minus x naught plus b times y minus y naught plus c times z minus z naught equals 0. We can also rewrite this in a more normal form with ax plus by plus cz plus d equals 0. By distributing all those values, coefficients a, b, and c, and combining all the like constants. Okay, so let's look at an example. Find the equation of the plane that passes through 1, -2, 3, and has a normal vector 6, 2, and 4. So this will be my n. This is going to be my p. We will want to follow the same format up here. So I'm going to take this p and write it like such. X minus x naught, y minus y naught, z minus z naught. So we should have x minus 1, y minus -2, and z minus 3. Okay. Now we can dot them. We're going to have 6 times x minus 1, 2 times y plus 2, and -4 times z minus 3. And we get such. If we go ahead and distribute, we can see that we got 6x minus 6 plus 2y plus 4 and -4z plus 12. Combining -6, 4, and 12 gives us plus 10 on the left. We could also go ahead and move to the right and make it minus 10 over there. So that's one example. Let's do another. We're going to find the plane we're going to find the equation for the plane that has points P, Q, and R. 2, 4, 1 is P, Q is -3, 5, and 2, and R is going to be 0, 1, 0. So let's, we got 3 points in a plane. 3 points make a triangle. We extend that flat triangle out in all directions, and we have a plane. So we need to find a vector that is normal to this plane. Any ideas how we could do that? Pause it, think about what you could come up with. All right, so one such option is we make some vectors. And if we take the cross product should give us a vector that is normal to both of those vectors, which would be n. So that's what we're going to do. Let's make PQ and PR. PQ is -3 minus 2, 5 minus 4, and 2 minus 1. We get the vector -5, 1, 1. We do the same thing with PR and we get -2, -3, -1. So let's take the cross product. N is going to be parallel to that vector. So if we do the cross product, we've got -1 minus -3, so -1 plus 3 for I hat. J hat's going to have the negative sign, but we've got 5 minus -2, so 5 plus 2 is 7. Opposite sign would make it -2. And for K hat, we've got -5 times -3 is 15. Minus -2 would be +2. 15 plus 2 is 17. So N equals 2, -7, 17. Now we just need to pick a vector and do P naught dotted with N equals 0. If we used P, because if we use P for P naught, we would get this vector or this equation. P was 2, 4, and 1. Bring that back down, 2, 4, and 1. So -2, -4, and -1. If we distribute, we've got 2x minus 4, -7y plus 28, plus 17z minus 17. Collecting like terms, we get 2x minus 7y plus 17z plus 7 equals 0. And write my other points down here real quick. And because I want you to see that it doesn't matter which point we use. There's my N, keep that on the screen. If we do it with Q, -3, 5, and 2 becomes x plus 3, y minus 5, and z minus 2. If we distribute, we've got 2x plus 6, minus 7y plus 35, plus 17z minus 34. Gathering like terms, 35 minus 34 is 1. 1 plus 6 is 7. We now have the same equation as before. And if we do R, we have 2x minus 7 times y minus 1 plus 17z. You can see relatively quickly we get that same equation. So it doesn't matter which point we use as P naught, as long as we have the right vector for that plane, you'll see we get the same equation for the plane for any of them. So I wrote it as AX plus CY plus, or BY plus CZ equals D. It's a plane with a normal N hat. As long as at least one component is non-zero, we do not want the zero vector for the normal, because that doesn't make any sense. Any other vector, even 1, 0, 0, means it's just pointing in the X hat direction. Okay? That'll bring this section to a wrap. Peace.